All right, welcome everyone. Today our main topic is going to be Installfest. That's going to be our NC, a full operating system which will be able to code all of our Django applications, our React application, and our full stack applications by the time we are completed within this lecture. Now, with that said, we're going to start at the very meat and potatoes and try to understand our operating system a little bit more. We're going to do a little bit of reading. We'll break up into pairs or groups. And then after that, we will reconvene and talk about how to work with the assignments here at Code Platoon. If you scroll down our lesson here, you'll see there's a computer setup, one for Mac, one for Linux, and one for WSL. All that information is there available for you. But as of now, as a group, what we'll dive into is what is Unix. So if I could get somebody in the class to read this paragraph, that would be fantastic.
I could go for it.
Let's see it.
What is Unix? Whether you are on an actual Linux system, Mac OS, or Windows with WSL, we are going to refer to all of these environments as Unix, or just the command line interface, CLI for short. So what is Unix? Without getting too deep into the weeds early on, Unix is an operating system architecture and set of tools that allows a user to interact with the operating system through a command line interface. It is the lingua franca of operating systems, i.e., it is a language you can expect almost any operating system to speak and allows you to interact with it in a predictable way.
Awesome. Thank you, Alex. So now there's a couple of details about Unix. So in reality, Unix started as a specific OS invented at Bell Labs in the 1960s by some of the same people who invented the C language. It was very popular, but also open source. So different operating systems copied the concept. However, there was a poor compatibility between the different implementations, a common theme in the history of software development, complicating things further. Software used to be deeply coupled with hardware and made to fit an individual product. So even within a given company, there wasn't a single OS that unified the experience across devices. All right, so let's break down that paragraph and talk a little bit about what that means, right? Because that's a kind of a bunch of gibberish unless you are capable of understanding what exactly it is they're saying. So an operating system, which is inside of what we're going to call our terminal, this gives us our CLI or our command line interface, something that we can type commands into or kind of introduce commands into that will get passed down to hardware to actually execute functions, right? So this is, we'll call it, let me do a little bit of formatting here. Boom, boom. All right, the CLI. And essentially, it is a place where we can write execution commands. And this is where connection between the user interface translates to hardware commands. Now, what do I mean by that? Well, let's say I have my fancy dandy laptop here, right? I'm going to try to draw one here real quick. Probably not going to look the greatest, so please bear with me. My nice little screen, my keyboard. All right, you guys get the idea. Well, if I have a folder here, or I go into my screen and I right click and I say make a folder, well, a new folder gets created and it gets saved into my machine. But what is happening inside of memory space? Or something even more interesting, let's say I click on the Slack app. When I click on the Slack app, all kinds of different lights start populating. Slack has a pop-up feature and then it takes over my screen. And all of a sudden I'm seeing all the information from Slack. Well, where's all that information coming from? Well, inside of my terminal, what ends up happening is a command such as, hey, I want you to open Slack happens. And open Slack is a directory or folder with executable code that interacts with hardware. And that's how everything came about. So now that we have a little basic understanding over the terminal CLI and how to communicate inside our computer, this is utilizing Unix. But what was happening back in the day is a different version of Unix or a different Unix-like language was being created for every single new system that was also being created. And as they were being created, they decided, hey, I want my user to have the best user experience, and I want my hardware to perform as optimally as possible. In order to achieve that, they made a one-size-fits-one system, where every single time a new system was created, well, a brand new version of Unix was also created, and so on. Now, by the time this ended, you ended up with a bunch of different Unix versions, all specifically made for one system, but they were not compatible across. If I try to fit this one Unix command to a system next to it, well, then the Unix command would simply just refuse. It would say, hey, we ourselves cannot connect. Oh, that's the wrong end. We cannot connect. My my hardware does not match the commands you're trying to execute within that Unix command. So how do we fix this? Well, a bunch of developers got together and said, instead of making everything tightly coupled, this is what tightly coupled means. It means there's a strong dependency between one system and one Unix version. They said, what if we change it so that we made one Unix version, and instead, as systems are being developed, they'll just have to adapt to that one version of Unix. So now, the common standard is where the more popular versions of Unix, which you'll see later on, there's a couple that are used. The most popular one right now is Ubuntu, is created, and as systems are being developed, they are made so that are different Unix, or excuse me, as different systems are being made, they're made to adapt to that one Unix script. Right? So now instead of being tightly coupled, it's loosely coupled. And it puts a little bit of harder work on the system designer because now they have a strict Unix system that they have to leverage. But it makes a much better experience technology-wise and developer-wise. Is there anything you want to add on to this, Adam, before I keep moving forward?
No, good to go.
All right. Any questions regarding this one paragraph? Okay, awesome. So that changed in the 80s with the invention of the personal computer and Apple and Microsoft becoming the most significant players in that emergent market. Mac OS based its OS architecture on Unix, whereas Microsoft went its own way entirely with Windows and MS-DOS. Then in the 90s, Linux was invented as an open source OS and defined the core kernel that all other Linux distributions or flavors are based on. Linux is odd in that sense, in that it is open source. So there isn't one Linux. There are a few popular flavors, but a million others that are just as legitimate, just not widely used. That means that in the modern age, we have Linux, which most closely based on Unix, but may differ slightly based on the flavor you go, which is either Ubuntu or Debian are the most common nowadays. Mac OS is not the same thing as Linux. It is very similar and is a very Unix-like, but will differ in small ways. really just a specific flavor of Linux, but one that Apple uniquely controls and is closed source as a result. Also, Apple has a habit of making breaking updates whenever they please. And then Windows. Windows is built on a fundamentally different architecture, and you will see this if you try to put Unix commands into command prompt or Windows PowerShell. Most will simply not recognize, even basic ones like ls, which stands for list. However, this was such a pain point for developers on Windows that they eventually relented, and the modern solution is WSL, which is Windows subsystem for Linux. Essentially, if you're on a Windows and suggesting is to use WSL, we'll dive into WSL later. I don't want to start reading this and take away from WSL portion. Now, the major take home is no matter the OS, we can all be on basically the same environment, but there will always be small differences that will make the behavior of Windows, macOS, Linux different. And even one version of macOS, for example, will differ ever so slightly from another. And this is what makes environment setup so difficult. We simply can't anticipate every issue that you might encounter given all the permutations that determine what makes your environment unique. Now, this last paragraph here, I'm just going to throw it in as like a 50 cents story for a future lectures, not necessarily something that you have to know now. But this paragraph here, this is the entire reason why Docker and containers became a thing. All right, so now we have Docker containers to solve this issue, but we'll talk about that later on. All right, now architecture. On a basic level, a computer can only run a single program at a time. So as an operating system, is the program your physical hardware is running. And by its design, it's an interface between the hardware and the user, which allowing other programs to be run on top of this main program. Think of the operating system like a scheduler. It's there to coordinate the sharing of hardware resources between multiple users and programs without requiring each one of those users' programs to know the intimate details of the hardware. Now, this diagram is pretty important here, so I'm just going to go ahead and copy this image and bring it out. All right, so here we have the application, shell, kernel, hardware, and then utilities. All right. Now, although I like this circular portion here, I like breaking everything up inside of boxes because I like to think of web development as kind of like a Russian doll, right? Every time you open one, there's another one inside, and everything inside of web development is just a bunch of boxes inside boxes. So here it's the application or user interface. Now you click on a button or you click some things, and that sends a command down to the shell. Now, after that command goes down to the shell, it goes down to the kernel. Well, then the question comes up, hey, I know what the shell is because I can interact with the shell, but what is the kernel? I guess a better representation of this would be where the shell is here. And the kernel is kind of like the final layer, just stacked on top of the shell to ensure that any command that's being executed by the shell is actually a viable command or something that's executable by the current operating system that you're in. So the kernel is more of a safety layer. It's to ensure, hey, what you're about to run is actually safe for the hardware that we have on hand, and it's not going to break anything. And then finally, there's a communication that goes from hardware, or excuse me, from the kernel and the shell down to the hardware. Now, once it gets to the hardware, it doesn't stop there. Once it finishes getting to the hardware responds. And it responds by interacting with the shell, again, sending completion information over to the application, and then finally showing something new to the user interface, right? So that's the workflow there. I click on something, when I'm clicking, like my computer is in a magical place where things are just being executed in the background. As I click or send commands, such as if I right click on my desktop and I say make a new folder, that executes a command in the shell that gets checked by the kernel, which then talks to the hardware. If it's something as simple as making a new directory, then it allots for memory space to be occupied by said directory. It stores the name inside of memory. And when all of that gets completed, it gives a success command to my shell and my kernel. And then my shell and kernel give a user interface. So in my actual desktop, I get that nice little blue folder that has my new folder with new information. Does anyone have any questions about this workflow here? Adam, anything you want to add?
No, sir.
All right, awesome. Let's go back here. We have the hardware, the literal hardware of your computer. It could be made by any manufacturer, but to interact with it requires the kernel. So named because it is essentially a layer that allows an operating system to command your hardware. To do things you will generally never touch the kernel. Despite it being necessary for the operating system to function, think of it like the engine of a car. It's how the entire thing works, but the domain of an expert, while you, the general user, will usually just interact with it. The shell, surnamed because it wraps the kernel. I got those two backwards. The shell wraps the kernel. So I'll flip that here later on. All right, so named because it wraps the kernel. This is how you interact with the underlying hardware at a level of abstraction that is safe for the average user. The shell is a command line, text-based interface, and set of basic commands and programs that will allow you to do common tasks a computer user cares to accomplish. This is the layer we will focus on most on this lecture. But finally, of course, there's the last layer of applications. No operating system would be complete without the ability to run arbitrary applications. The command Python is itself an application, one that can read and execute text documents that follow the Python programming syntax. An application is any program that isn't essential to the operating system and therefore isn't built directly into the shell. But a modern shell generally provides an interface for downloading and running such applications. All right, that was a lot of reading. We're about to get into some commands here, but before we push forward and actually start writing some commands inside of this terminal, I'm going to go ahead and open up the floor for questions. At this point, does anyone have any questions over the material that we just covered or anything we've discussed? Carlton?
You might be muted.
There we go. There we go. Yeah, just a quick question about like kernels. I think I understand mostly what kernels are doing, but I don't know if you can explain like what happens in like a kernel panic. Um, I came across this recently whenever I tried to update a Ubuntu machine. I had custom drivers for what do you call it? Current custom drivers for video cards, and whenever I tried to update the kernel, it just completely failed.
Interesting. Yeah. I think I would need to know a little bit more about the situation in order to answer
Okay.
that. If I could answer that. So we could probably meet at a different time, Rick, and then I'll address that question.
Oh yeah, I just had to roll back the kernel, and it worked just fine. But
Oh, perfect.
yeah, I was just curious what actually happens during like a kernel panic. If you knew, I can look up that stuff on my own.
Yeah, I'll have to search that up. I honestly don't know it off the top of my head. All right. Any other questions?
And I do want to encourage folks to fire away with any and all questions. That's very much what we're here for.
All right, perfect. This is gonna be AJ.
I know you said if we're writing code that you can't pause for us if we fall behind, but if we do want to write code with you guys, is there a preferred program we should have open or something like that if we want to give it a shot?
Today we're mainly going to be writing stuff on the terminal. So if you just, are you on Mac or Windows?
I'm on Windows.
If you're on Windows, you're going to have to wait until after you install WSL. So I would just wait to write any commands down. Just write it down on pen and paper for now.
Okay.
Later on, you'll have an actual Linux shell that you can write commands into.
Okay, because during the orientation I did download Docker and WSL as well from your recommendation. You guys told us to.
Yeah,
Thank you.
awesome. Thank you.
And also,
Um,
guys, oh, sorry, go ahead, Francisco.
Yeah, I just want to tell everybody to precaution, especially if you're on WSL. Let's wait until we set up your terminal and make sure that terminal's set up correctly as far as like linked and mounted onto your operating system before you open it and start writing commands inside of it. All right, my bad. Go ahead, Adam.
No, that's a great point. And I was just going to say, folks, once we get into like a lot of our teaching, we'll be writing code. But all the code we write in class will also go into our demos and notes GitHub repository, which you all will have access to. So you won't have to worry about losing information. I think the value really of like writing pen and paper notes is to help mentally absorb the things as we're teaching.
All right, awesome. Let's go ahead and continue pushing forward now. The next thing we're going to talk about is a file and folder structure. When we start talking about file and folder structure, we'll start going over a couple of commands onto how to navigate between those files and folders. So everything in your machine is actually just files and folders. If you open up your terminal, you'll find that inside of your machine, so I'll go ahead and call this my machine, there is a series of directories, which are also called folders, and one of them is the desktop. There's desktop. I think the most common ones that I've seen is downloads. And then there's applications as well. Now, everything inside of your machine is actually nested. So what do I mean by nested? Let me go ahead and color code these a little bit so that they have a better visual representation. If I grab my desktop and I open it up, inside a desktop, I may have some other directories. Inside of these other directories, I may have something like, I don't know, trip to Hawaii, let's say that. And that might just hold a bunch of photos, or it might hold some documents and receipts. I may have something along the lines of notes for Platoon. And I may have an entire different directory saying Code Platoon, admin, files. So I can keep my own record inside of them, right? Well, all I did was open up one of these nested boxes to take a look at everything else inside of it. Now, let's say I open up this trip to Hawaii. And in this trip to Hawaii, I have both files and directories. Maybe I still have a directory that I decided to name pictures. But on top of that, I have files. Oh, that is not a good, that will work. Something like a travel voucher. And maybe I also have a file that's keeping track of the rental car. Well, now I can take a look at these files. If I double click them, it'll open them up in some sort of program inside of my machine that I have set as default. But here you can see the explanation of how everything is just boxes inside of boxes, right? If I were to take this machine out and bring it down here, well, I have my machine, which would hold the desktop directory. Inside of the desktop directory, I would hold my trip to Hawaii directory. that would also hold all of my files and pictures for the trip to Hawaii. All right, so everything is just boxes inside of boxes, nested within. I can just travel inside each one of them and take a look at them. All right, does anyone have any questions over this visual representation of files and directories? Doesn't look like there's any questions. And I can see by the class that this might be material that we all already pretty strongly familiar with. So I apologize if this is all recap for the majority of you. But it's important for me to ensure that this information gets covered, just to ensure that everybody's on the same page. All right, perfect. So now currently I'm inside of my directory Installfest. There's a command called ls. Now this command stands for list, and it's going to show me all of the current directories and files within this one directory. So you can see we have Installfest, that's the directory I'm currently in. When I executed the command ls, it listed that I only have one file named readme.md. So if I go to draw this picture out here, I have my one file named Installfest, and this is actually one-installfest. And in there, I have one file named readme.md. Let's say I want to make a couple of directories here. I'm going to make a directory. I'm going to call this practice 1, or I'll just call it practice. And I'll make a different directory, and I'll name this one Romeo. Now if I run ls, you'll see that I have both Romeo and practice that have been added. And then I have readme.md. So now my directory looks something like this, where I have Romeo and I also have practice. Great. I'm going to go ahead and dive into practice, which means I'm going to open up practice. Now, instead of saying open a directory, what we're going to utilize now is we're going to utilize a command called cd. Now, this command stands for change directory. And what I want to do is I want to change directory into practice. You'll see in my terminal that something has changed. Now, before this percentage sign, before I had one-installfest. Now I have practice. And if I execute the command ls, it's now going to be empty. That is because my practice directory is currently empty. There's nothing in there. Well, I'm going to make a file. In order to make a file, you utilize the command called touch. So touch, and I'm just going to call this main.js. And now if I run ls, you'll see that when I first ran it, there was no output from the command line. Now there is an output. The output is main.js. So now practice holds a file named main.js. Okay. Well, now what if I wanted to go back a directory? Well, I can utilize the change directory command, but I can't say that I want to go back to one-installfest because one-installfest doesn't exist in the information of practice. If I run ls, practice only knows about main.js. Interesting. Well, there must be a way for me to go backwards. Well, the way for you to go backwards is to execute cd period. Now, cd period, this is just a path. This isn't anything fancy. I'm giving it a relative path here. I'm saying from this directory, that's what the first period stands for. And the second period says, I want you to go back one directory. And now that puts me back inside of Installfest. If I run ls now, you'll see that I have practice, readme, and Romeo. Well, why is it that I can't see main.js inside of practice? Genuine question for the class.
Oh, I think someone might have said something, but they might have been muted over here in the classroom.
Oh.
No,
Yeah, sorry, I had a mute on my headset as well. I was just saying it's not in the directory that you're currently in.
Right. So currently, if I run ls or if I look at the directory that I'm in, I'm only inside one dash installfest. And one dash installfest only knows about Romeo. It knows about the practice directory, but it doesn't care about anything that's nested inside of practice. That's outside of my installfest scope. And then it cares about readme. That's why it's showing me that information. Well, now what I want to accomplish is I want to enter the Romeo directory. And I want to create a file named main.py. So how would I go about doing that? Knowing the commands of cd and touch. And now I'm going to go ahead and start calling on people. Rick, thank you so much, but you've answered a lot of questions so far. So let's start with Chris.
Yeah, so you'll do cd space Romeo and then touch main.py.
Nice. And now if I run ls, we can see that main.py has been created. So now what I have here is we have Romeo. And Romeo is currently holding a file called main.py. Nice. So we're able to change directories back and forth. We're able to see the current items inside of a directory, and we're able to create new files and or directories. Actually, we haven't talked about making new directories just yet, did we? Oh, I did quickly touch on that. All right, so when you make a directory, yes, very briefly, when you make a directory, you'll utilize the command mkdir, and that's what creates a directory, whereas touch creates a file. So let me go ahead and add some notes here before we start moving forward. Here we have our Installfest notes. Inside of Installfest, for part 1, we'll talk about the command line interface commands. Okay, the first command that we covered was ls. ls lists all items within the current directory. We've talked about make directory, which creates a new directory, otherwise known as a folder. We've talked about touch, which creates a new file. And we talked about cd, which changes a directory to the dictated path. So let me change that for path. Now, common examples that we saw here for change directory, we saw cd ... which means go back one. All right. Now for this ls, there is a little bit of a complication here. So you'll see that we're in this one dash installfest. And when I run ls, let me clear my terminal here. You see practice, readme, and Romeo. Well, that's what we expect to see. But if I run ls-a, you'll see that there's a couple of other hidden paths here. There's a period and this ... Interesting. Well, where did those come from? what is it that this -A flag actually changes? Well, there's such a thing as hidden files or hidden directories. And hidden files and hidden directories are hidden and they because they have a period at the front of their name. So files with a period in the front of their name will become hidden from the terminal. So let's just do a quick annotation here. Let's do files with a period in front of their names will be hidden by default. Now, if I want to see some hidden files, I need to pass the -A flag, which stands for list all files. So I should change this for list non-hidden items within the current directory, which this lists all items within the current directory. Right, so ls will list everything that is not hidden, but if you need to see any hidden items as well, you should run ls-a. All right, any questions over these few commands? Let's hear it, Chris.
Yeah, I was just curious when would we have to use a period? Like, what kind of files would we be hiding?
Yeah, it's a great question. So by default, whenever you make a Git repository, there's going to be a .git directory that gets basically inputted into your master file, right? So wherever your project is the root of your project, and you go into say Git init, a .git directory is going to be created. Now that one is important because if you want to create something like workflows or anything that interacts with GitHub, they go inside of that directory as well. Right. There's also something like environment variables, things that you want to make sure that stay hidden whenever they're pushed into production. Those go into something called .env files, and those .env files will also be hidden from the terminal. There's git ignore files, which are things to tell GitHub, like whenever it's tracking your repository history, and we'll cover this tomorrow. Hey, don't look at these files because these files are going to be just trash collection files or garbage collection files that you don't really need to worry about. So you add them into a git ignore so that it's not constantly being pushed into your Git history. Does that answer your question, Chris?
Yeah, I guess I was just curious if we would ever be creating our own like dot whatever file name it's going to be. Like, will we ever create a file and then hide it?
Yes, you will. So those files that I just mentioned, those last two files that I just mentioned are some that we'll create on our own.
Okay, thanks.
Of course. All right, Alex.
So I've been trying to practice a little bit using the CLI, and I'm on Mac OS. And to open any of my applications, I have to type -A. Uh, but I don't think, like, say Google Chrome, for example, I have to type open-A and then Google Chrome. But I don't believe that the Google Chrome is hidden.
Yeah, so the
So,
-A flag. Oh, sorry. The
no, my
dash
bad.
You're okay. The -A flag has different meanings depending on the command that's following it before. So for example, here we have list, which is the original command, right? From there, that's going to have a couple of different flags utilized with it. One of them is -A, which in this case, it stands for all, right? But for example, if utilizing open-A, the -A no longer stands for all. Likely, I would assume that it stands for authenticate, but I'm not sure off the top of my head as
Got
to
it.
what that flag means when it's followed by that command. Does that
Okay, that
answer your
makes
question?
sense. Yes, sir.
Okay, awesome. Rick?
Yes, actually I raised my hand to just share some information, and actually his question leads perfectly into it. Is every command inside the CLI has different flags that you can use. There's thousands, some have thousands of flags, and I just put it in chat, but good documentation to go to is the Mozilla developer MDS. You just look that up on Google and you can find flags to just about any command.
All right, awesome. Thank you so much for sharing that. And yes, definitely hundreds of flags out there. They will drive you crazy whenever you're making shell scripts, but that's what they're there for. They're there to make your life simpler by making it just a tiny bit more difficult. All right. Now let's go ahead and keep moving forward here. We've talked about a little bit of file paths. Now that we know that information, let's scroll down our curriculum here. I believe there's one more command here, which we should talk about, and it's pwd. Now, pwd stands for print working directory. And this is going to be useful once we're starting to reference paths and trying to attach different files to one another. Just for our own essay, when you type pwd, it's going to give you a direct address as to where you're currently located inside of your machine. Inside of my machine, I'm in users, Francisco Avila, desktop, Buffalo demos and notes, 01-py-intro-installfest. All right, everyone. So now that we've talked about all this information, before we continue moving forward, we've been going on for about an hour. Let's go ahead and take a 10-minute break. Currently, it is 9:47. Let's come back at 9:57 and continue on with part 2 of our lecture. See everyone back in 10 minutes. Great, welcome back, everyone. Now, we've covered PWD. We saw a little bit of how to maneuver around our operating system and even how to create some paths. We're not going to talk too much about these absolute and relative paths just yet. We'll dive further into that once we're inside of Python. The next thing we're going to be dive into is going to be file management. Now, we talked about how to make a directory. We talked about how to make a file. But there's a couple of other things that we can do here. We can also copy a file, and we can move a file as well as removing them. So let's start off there. Now, this is my current directory or my current folder structure. I want to change some things around. I actually want to put readme.md inside of practice. Well, if I look at ls, I have readme.md available to me, and I want to put it inside of practice. Well, I can do that utilizing the mv command. And actually, let me cover a couple of purposes here for the mv command. The mv command can also be utilized to rename something. For example, if I take readme.md, I can say, hey, I want to rename this into my practice.md. And now if I run ls, you'll see there's no more readme available to me. There's just my practice.md. And if I want to rename it back again, well, I can go into my practice and name it my readme.md. And now if I run ls, you see that we're back to our regular folder structure. So that's how we rename a file, is utilizing the mv command, which stands for move. Well, I can also move a readme, and I want to move it inside of practice. So you'll see the structure here where I moved, there's the file to be manipulated, and then the destination where I want it to end up at. Well, now if I run ls, you'll see that there's only practice and Romeo. So what just happened is I took this readme, and it is now officially inside of my practice directory. If I say ls practice, you'll see that it shows me my main.js and readme.md, which is exactly what I had depicted here on the right-hand side. All right, well, what else can we do? As of now, Romeo doesn't have a readme. What if I wanted Romeo to also have a readme.md? And let's say that I wanted to have the same exact information. let's say a couple of commands that we're going to cover here to accomplish this. One, I want to put some information inside of this readme.md. So we're going to cover a kind of, I would consider it advanced concept here. This is called the Vim. Now in Vim, we can utilize Vim to actually manipulate a file, such as inputting text, changing some text, and saving that file. Now Vim is old. It's from before there was a mouse. It was pretty much the original computer interface. Well, now let's go ahead and try to exercise this. I'm going to one, change directory into practice. I'm going to run ls. You can see main.js and readme.md are there. Now, if you are following along, I suggest that you stop here while I do the Vim manipulation, just so you don't get stuck inside of Vim, which is a common and embarrassing thing that does happen. So we're going to go into Vim and dive into readme.md. So you'll see here that it gives me a little bit of a heads up. It's telling me, hey, files with a dot in front of it, their names will be hidden by default. Oh, it looks like this is actually the original information that I was typing out earlier inside of that README, which is great. I'm gonna go ahead and utilize the insert command, and I can insert by pressing I on the keyboard. Now, by pressing I on the keyboard, you can see that square. Go ahead and highlight it here. There's the square here that's going to be blinking here shortly. All right, so that square is what tells me where my current cursor is located. A couple of command line shortcuts are going to be taken away from me, which is okay. And I can actually go ahead and enter a couple new notes. Or I can say, hey, inside here, I want to add the mv command, which takes in the file to manipulate and the destination. And this is utilized to move a file. We'll call this an item from one directory to another. All right. And now we're talking about Vim. Vim, and then the file. This is utilized to update, read, or delete information from a file. And actually, we'll go into write, not read. Like write, read, delete from a file. Now I've added all of this. And if I take a look at my current state of my file of readme.md, you'll see that nothing has changed. Right? I can open up practice and I can see readme. Nothing has changed. Right? That last line or those last two lines for mv and vim aren't there. Well, how do I actually save this information? Well, here on the lower left-hand side, you can see that there's this dash insert. Well, what this dash insert means is that my terminal is my Vim is currently in insert mode. Well, if I press the escape key on my keyboard, that insert mode is now gone. Right? There's no more insert mode. Awesome. Well, now down here, you're going to see the commands that I write. So for example, now that I want to exit, well, I can do colon. That means, hey, here is a Vim command that you're about to execute. And what I want to do is I want to write this file, and then I want to quit Vim. So I want to write the changes that I've made and then quit Vim. WQ again stands for write and quit. The colon is what lets Vim know that this is a Vim command. And now when I press enter, it returns me back into my original file. But how do I see that those changes were successfully saved without having to open up VS Code or having to open up the file itself? There's got to be a command in my terminal that I can use to be able to view this information. Well, there's actually something called tail, and then I can say the file name. So tail file name will show me the tail end of a file name, such as now we've added the mv command here, and we've also added the vim command as well. If I go to VS Code, you'll see that both of them are present, and I forgot to add some backticks there. All right, both mv and vim are present as well. Now, just like there's something like tail, there's also something like head. You'll notice that tail shows me the tail end of the file. Well, if I type in head and then run readme.md, that shows me the head of the file. All right, well, what if I wanted to see the entire file, right? I don't want to just see one thing here. Well, I can run cat and then the file name. And if I run cat, it shows me the entire file from one end to another. I'm gonna go ahead and clear my command line here. Now you'll notice the cat showed me the entire file. And that's not really a big deal when I'm working with such a small file as of right now. Currently my demos and notes is only 13 lines. Not a big deal if I run cat. But if my file was hundreds of lines of code, that might turn into a problem, right? What if I wanted to look at a specific information or a specific set of data within there, or I want to see the previous history of my terminal? Well, in there, I can run something like less and then utilize readme. Now, what that allows me to do is click on the spacebar to scroll on the file without occupying my entire terminal. And once I get to the end, you'll see there that it tells me, hey, this is the end of the file. I can just press Q and it'll return back to my terminal. All right, a lot of information was just covered. I see a couple of hands up, so let me go ahead and pause here. Thomas?
When using head and tail, how does it determine where the cutoff point is for displaying the information?
Yeah, it's a great question. I believe it goes by number of characters. I don't know at the top of my head like what the limitation is here. Head file limitation. Let me see if it goes by lines of code here. Okay, so by default, it comes with a line of code limitation. But it doesn't have to have the limitation. If you pass in the -n flag, it'll actually read the entire file without a problem. But it goes by lines of code, not numbers of characters. And what I mean by lines of code is each one of these here on the left-hand side. So even if they were empty, they would still be considered a line of code. Does that answer your question, Tom? All right, great. Alex?
So, those last four commands that you gave, which were tail, head, cat, and less, were you within Vim
No.
when you were writing those, or those are just regular Unix commands?
Those are regular unit commands. By
Got
that
it.
time, I was
Okay.
out of it.
Understood.
Yeah, so let me go ahead and add these couple of commands here. So pressing I on keyboard within Vim will place Vim in insert mode. pressing escape on keyboard. We'll exit back into Vim mode. And then the command of WQ will write the file and quit Vim. There's other commands such as Q, which will not write any changes, and quit Vim. All right, awesome. And let me go ahead and do this one. This one is rare, but in case you need it, that's quit by force in case Vim has unexpected changes. Every now and then, if you make a couple of changes to your file and you decide, you know what, I don't want to do this and I want to quit, Vim might tell you, hey, you have changes to files and you didn't write them. So what do you want to do with them? We can't just quit. If you do quit dash force, it's essentially going to disregard all the changes and get out of it. All right. Now, commands that were not in Vim, such as head and then file. This command was utilized to see the head end of a file, which is the start or top. This one was tail file, which is to see the tail end of a file, which is the end or bottom. We had cat, which was to view the entire file at once. And then we have less, which was to view a file by scrolling through sections. All right, and then exit by pressing Q. Okay, awesome. So there's a couple of commands that we have there. Alex, is your hand up for a new question, or is that just old? Old, got it. All right, couple of commands that we just made up there. And now let's go ahead and continue on with our copy command, which we haven't seen just yet. Now, currently, if I run ls, you'll see that I have main.js and readme. And I want to copy this readme over to Romeo. Well, I can run cp, which stands for copy. The command that or the file that I want to copy is readme.md. And I want to tell it where to dump this copy of the file. So I'm going to say I'm going to go back a directory that puts me at Installfest, and I'm going to place it inside of Romeo. Well, now, what ideally just happened is I copied my file and placed it in Romeo. Let's make sure that's true. I'm gonna change a directory back. That puts me at Installfest. You can see that I have practice and Romeo there. I can change a directory into Romeo. And there I can run ls, and now you'll see there is in fact a readme in there. And if I want to see the contents of said readme, there's my readme, there's installfest CLI command. It's telling me this is the entire file, so this is the end of the file. And we can see that everything is up to less. Great. So let's go ahead and add that command there, which is cp file that is going to be manipulator or copy, and then the destination for dropping off the copy. So this is utilized to copy a file and drop copy in a designated directory. All right, awesome. Now, what happens if I want to make a copy of the file and dump it inside of the same directory? All right, so currently I have Romeo. What if I want to do something like cp readme, and I still want to dump it inside of Romeo, maybe like as a backup? Well, I can have this and tell it that I want to drop it as a different name. I want to drop it as backup.md. Excuse me. So there's Romeo. You can see here's the original README that is inside of Romeo. And if I click on backup, there's an exact copy of that file, but now holding the backup as well. All right. Any questions regarding the CP command? Let's hear it, Arnold.
So just to clarify, when you do a copy, do you have to go inside, let's say for your example, Romeo, or can you do it in the Installfest and then you just do README and then change it to a file, change it to a to a destination?
Yeah, that's a great question. So everything can be executed from the root directory of Installfest, right? So as of right now, the most updated one is going to be the practice README. We know that the practice README holds all of the information that we need. So I can go back a directory, and now I'm inside of Installfest, all right? Let's say I want to copy the README inside of practice and dump it inside of my root directory, where I can run the cp command, and then I can specify the path to practice readme.md. So I can say inside of practice, there's a file named readme.md. I want you to copy that file into this destination as readme.md. And I really don't need this last portion. I could just say into this directory. All right. And when I execute this command, now if I run ls, I go back to the original structure where I had those two directories. And on top of that, I have the README file, right? So the structure never changed. All I did was I still passed the file that needed to be manipulated. I just passed its location where that file was at, rather than going into that root directory. Did that answer your question, Arlen?
Yes, but just to clarify, instead of putting the // can you put in the name Installfest there to reiterate it, or no?
You can, yes, you can go ahead and let me go back here. So you're saying I go into CP practice readme.md and then call it Installfest.
Yeah, yes.
Now I have Installfest as well.
Oh, so it's okay.
All right. Now let's start cleaning everything up. We just made a bunch of directories and a bunch of files, all to make sure that information was located in the right place. Well, now that we got some practice into doing a lot of maneuvering around and managing our files, let's talk about how to delete all this info. So I want to start removing information. Well, I want to remove a file named installfest.md. That's what RM stands for. It stands for remove. Now when we're going to run it ls, you'll see that installfest.md is no longer in there. Well, what about practices? Well, there is such a command as make directory. So you would think there's got to be a command named remove directory. Let me try to pass that into practice. Well, the command remove directory does exist, but you'll notice that it comes up with an error if it's not empty. So if I try to remove the practice directory, it tells me, hey, this directory isn't empty, so we can't execute this command. Now, let's say I make a directory dummy, and then dummy exists, right? Well, now if I were to remove directory onto that dummy directory, it succeeds. So this rm directory only works with empty directories. Well, that kind of poses a problem for me. Does that mean that I have to go inside of each one of these directories like Romeo in practice and remove each independent file one at a time before I could actually remove the directory? That doesn't look very efficient. So there's got to be a better way of removing these directories here. Well, what is the best way to do it is by doing remove command. You do -rf, which stands for -r is recursively and the f is by force. So I'm going to recursively remove all of the files and directory within Romeo, meaning it will remove main.py first, then it will remove the readme.md, and then finally it will remove Romeo. And now when I run ls, you'll see all I have left is practice. So pretty much all I did was remove all of that. All right, now this rf-rf command, it's likely the more, or I would say that it's the most common way of managing directories nowadays, as far as getting rid of them and removing them. It's like the common standard of, hey, I got to remove a directory, but it has a bunch of files inside of it. I'm going to use rm-rf. Now, this rm-rf, remember, it has the -f flag. So it's saying we're going to be doing this by force. It's not going to ask for any sort of confirmation as to, should I remove this? When do you want this removed or anything like that? It's just going to, as soon as you press enter on the keyboard, iteratively start removing each independent file one by one, all the way until it gets to the top directory. So if I'm in the root directory of my computer, which is where you're going to be at every time you open up the terminal, and I run the command rm-rf, and I don't put any path to follow it, and all I execute is rm-rf, it's going to assume that I want to remove all of the information within the root directory of the terminal that I'm currently open. So that means that my entire laptop potentially could be deleted, right? So please make sure that you're very careful when you're utilizing this command, rm-rf. Make sure that you follow it with a command, that you specify exactly where that's at. I would just say be potentially more conscious whenever you're typing that command into your terminal. All right, Arnold?
Yeah, so is there any way to undo that, or is there like a backup?
No, because we utilize the -f flag, everything's getting deleted right there and then. All
Okay,
right,
thank you.
of course. The next thing is going to be rm-rf, and then practice. That removes my entire practice. And now back to a single directory called Installfest with one file inside of it named readme.md. Let's quickly add those commands there. So the command that we just covered was rm, which removes a file. The next command that we covered was remove directory, and then a name of the directory, which removes an empty directory. And then finally, we utilize rm-rf directory, which removes all items and or within a directory along with the directory itself by oops. All right. That's going to be all the commands we're going to be covering today before diving into our actual environment setup and Installfest. So before we move into that second portion, I do want to open it up for questions. I see a question from Tom. Go ahead.
Yeah, with the remove command, is there a way to say, I don't know, say you have like 5 files in a directory, maybe more. say you want to delete 3 of those files, just looking at scalability, is there a way to remove like 3 of those files at once? Or do you need to manually
It's a
remove
column.
3 of those files?
It's a column.
Yeah, that's a great question. Sorry, Arnold, was there something you were trying to add? Okay, awesome.
Yep.
All right. Now, when it
Awesome.
comes to the solution for that question, you could either remove a file at a time manually, or you can write a script that will essentially do a while loop. And then while it'll start iterating through each one of the files and instead have a counter. The shell the shell has a specific language called ZSH, and you can actually write code in ZSH that will execute this one function for you. But you're still just executing one file at a time. It's just inside of a script now. Does that answer your question, Thomas? All right, awesome. Any other questions? Okay, great. It doesn't seem like there are any other questions. It is now 10:27. Let me go ahead and stop our recording here.